Hello, Calculus. We are doing some polynomial division, and we have this question 4 from our limits quiz. Here's the question. We have a function f of x defined as x cubed minus 9x over x cubed plus x squared minus 8x minus 12. And the question basically asks us what's going on at x equals negative 2 and x equals 3. Okay, so the first thing we do is we just try direct substitution, or we just plug those numbers into that function. And for 2, we find out that there's a vertical asymptote at x equals negative 2. And we know this because it's, we plug in the 2 and we get 10 over 0. And anything, if we have something over 0, that tells us there's a vertical asymptote there. And so x equals 2 is a vertical asymptote. Now, for x equals 3, it's a little bit different. We plug in the 3 and we get not something over 0, but 0 over 0. This is a different case. This is called indeterminate form. So notice that these two things are not the same thing. 10 over 0 means vertical asymptote. 0 over 0 is indeterminate form, which basically translates to we don't know what the heck is going on here. So we've got to try some strategies. And the first strategy we try is let's do some factoring. And so we know from a previous problem that this top x cubed minus 9x factors into these three terms, x times x minus 3 times x plus 3, all of that over the original term. And that's just from experience, that's just from a problem we had done earlier. And now we look at this and we say, okay, well, our problem is 0 over 0. So how can we make the 0 go away on top at x equals 3? What's causing it to be 0? Well, we plug in 3 here, we plug in 3 here, so 3 minus 3 is 0. So 3 times 0 times 6, it's this term right here that's causing the numerator to be 0. Anything times 0 is 0. So wouldn't it be nice if we could factor out this term? Yeah, it would, but I look at that and I think I have no idea if x minus 3 is a factor of this beast down here. So how do I do that? I don't see any obvious pattern. Well, this is where we turn to polynomial division. And we can flip over and see that right here. So we've got, we want to find out, does x minus 3 go evenly into that x cubed minus x squared minus 8x minus 12. And no, it's plus x squared. Okay, so we do some division, just like the same kind of algorithm that you did when you learned log division, but this is just a little bit trickier because it's polynomials. So the way we do it is we look at this, just this x and just this first term, and we ask ourselves, well, what would it take for these to be equal? We would have to multiply this term times x squared. So we put that up top, and then we take this x squared, and we multiply it by each term in the divisor. So x times x squared is x cubed, x squared times negative 3 minus 3x squared. And then just as in long division, we subtract. So we're going to take x cubed minus x cubed, so that's 0. And then x squared minus 3x squared, so minus a negative 3, so that's a positive, so it's going to be 4x squared. And then we just bring down these terms here and we repeat. So now we ask ourselves, okay, how many times this x go into 4x squared? Well, it looks like it goes in there 4x times. So now I take my 4x and I multiply it by x, and I get 4x squared. 4x times negative 3, and I get minus 12x. And then I subtract again. And this is 0. Then negative 8 minus a negative 12. So that's a positive 4x. And then I just bring down the 12, because it's basically minus 12 minus 0, so it's negative 12. And I do one last time. How many times does my x go into 4x? Well, it goes in there 4 times. And I take the 4 and multiply it by the x, so I get 4x. Take the 4, multiply it by negative 3, and I get a negative 12. 4x minus 4x is 0. Negative 12 minus negative 12 is 0, so it goes in there evenly. Sorry, I left you out of that bottom part of the problem there, but it all worked out very nicely, and we divided x minus 3 into x cubed plus x squared minus 8x minus 12, and we found out that this does divide in evenly, so x minus 3 is in fact a factor. Okay, now we can just come back to our original problem, and we'll be able to cancel out those x minus 3's, and we then no longer have indeterminate form, and bottom line, we're going to find out that 3, x equals 3, is simply a point discontinuity. And now, once we factor out those x minus 3's in the numerator and in the denominator, we're left with something that does resolve itself into a finite number, and we realize that at x equals 3, it was a point discontinuity. Okay, I hope that helped. That's question 4 on the quiz. Polynomial division.